So when we're looking at reference angles, so if we've got 130 degrees, we can reference the angle to the 50 degrees in the first quadrant. What we want to reference is we want to find what the equivalent angle would be in the first quadrant, because it sort of makes a bit of sense and we can really understand that. I'm just going to take a snippet of this. So what I mean by that is, well, if this is 150 degrees over here, we know that this value right here, okay, this value here is going to have the same values over there, which is going to be 50 degrees from here. So we can call that as a 50-degree reference angle. So if we knew the values that was sine and cos here, we could tell you what the values are there. Except I know that the angle here is going to be, because this is actually, I know that sine 130 will be the same thing as sine 50. Why do I know that? Why do I know that this is the same? Is because if you know what sine is actually the value of the y. Don't forget. The y coordinate is going to be the same there and there, okay? Because don't forget, sine angle is your y coordinate. Your x coordinate is cos, because it's adjacent over hypotenuse. This angle, if we have 50, it will be adjacent over hypotenuse because the hypotenuse is 1. This is just the value of cos. Whereas opposite over hypotenuse, we know that this is the value of sine theta, and that's why that is after yesterday's lesson. So I know that cos theta is going to be my x value. Cos 130 degrees is going to give me an x value from here to here. It's going to be that length, which is that point there. This is going to give me a negative answer. If I referenced it to cos 50, I know that cos 130 is going to be the same absolute value, ignore the negative, positive, a negative or positive absolute value. It's going to be the same absolute value of cos 50, except I know that because this is going to give me a negative answer, this will give me a positive answer, because cos, when we're talking about cos, we're talking about the distance here. So it's going to give me a positive, cos 130 is going to give me a negative. So to make it the same, I need to put a negative on there. And that means 130 degrees cos is the same thing as negative cos 50. So let's have a look at the calculator. If I bring up my main, and we'll just clear all this, make sure we're in degrees in this mode. We're not dealing with radians yet. So if I do sine 130 degrees, oops, that would be the same thing as sine 50 degrees, because they're both, 150 degrees, 50 degrees, they're both at the same y value. However, I know that cos 130 degrees would be negative, right? Same thing would be as negative cos 50. Oops. Negative cos 50. The same value, because cos 50 itself would be the positive value of that. So putting a negative in the front makes that a negative value. And that's why we call these our reference angles. We try and reference all the angles around, quadrants 2, 3, and 4 back to quadrant 1 to make sense of it sometimes. And that helps us get through it. That's what we call a reference angle. So we have a few different things. We can look at quadrant 1. We know that cos and sine are both going to be positive. Over here, I know in quadrant 2, cos is going to be negative, sine is going to be positive. Over here, cos is going to be negative, sine is going to be negative. Over here, cos is going to be positive, sine is going to be positive. So if I said, hey, if I had just say my reference angle was, let's just take a snippet of this one. If my reference angle is, let's just say we have a reference angle of 330 degrees. Okay, 330 degrees would be like this. And we know that's going to be 30 degrees from here. That means my reference angle would be in the first quadrant. Now we should know what 30 degrees is. So really, if I asked you what sine 330 degrees is, let's reference it back to what would be equivalent in there. sine 330 degrees would be the same thing as negative sine 30 degrees, because sine 30 degrees would give me the same length as 330 degrees, because remember, we start from here, we actually go all the way around, and that's going to be 330 degrees. 360 minus 30 degrees would be 330. So we know that in here, this is 30 degrees, and it's the same thing as a 30-degree triangle here. And we know that sine is a half, okay? That's going to be a half as well, the length of this, but in terms of coordinates, that's going to be negative a half. So the coordinate here on this one is going to be root 3 on 2 for cos, and it's going to be negative a half. So this coordinate would be root 3 on 2, and that would be a half. So that's why I've got to put the negative in front, because I know that sine 330 would be the same thing as sine 30, but the negative of it. Cos 330 would be the same thing as, though, cos 30, because they both give the same value, which is root 3 on 2 for that one. Remember, tan is the value of sine divided by cos. So when we're looking at reference angles, we have these reference angles here. Okay, so you can reference those two. If you've got this quadrant, you're going to have to think of like that minus pi, and 360, we can think of 360 minus the theta angle to get our reference to there and what the angles are. Really, hopefully you can just draw the triangle and we're always referencing it off the side. What I mean by that is our reference angles, we're always going to reference it and draw triangles like this, basically from the horizontal on the x-axis is where you're going to reference and build your right angle triangles from. You always build them from there, pretty much. You can build them from the other way as well, don't get me wrong, but it's a bit easier to see it from that side. So that's pretty much the reference angles there for you guys. So that's where we're sort of going with that and where we're going to go. So when we look at using a reference angle, write the following using their reference angle. So sine 330, well, we just did that one, is negative sine 30. Cos 162, okay, if I think about it, cos 162, what I try and do in my head is like I sort of think about it and I think of, okay, cos 162, if you think about the reference angle, that's going to be 162 over here. So the reference angle, if you think about it, is going to be 180 minus 162, which is going to be 18, because you're actually thinking of this triangle in here, 18 degrees, and my reference angle for that. So if it was cos 162 degrees, I know that's going to give me a negative answer. My reference angle would be the 18 degrees in here, so I know that is equal to negative cos 18 degrees, because that would be the same length as that, except that's going to give me a negative coordinate, so that's why that's going to be a negative answer. This section here would just give me a positive section, so I've got to put positive answer, so I've got to put the negative in front to match it up with that. Yeah. The second question, tan 230, is a bit trickier. So if you think about tan 230 is going to be 180 plus 50, so it's going to be like 50 degrees here. Now, you think of sine is going to be negative and cos is going to be negative. Tan is that divided by that. So tan is going to be positive. Over here, sine is positive, cos is positive. That means those two divided by each other, sine divided by cos, is going to be positive. So I know that tan, what are we, 180 plus 50, 230, is going to be equal to tan 50. Alternatively, we could also make a few of these. And we could also say that if you had 50 degrees in here, well, I know that sine is going to be positive, but cos is going to be negative. So positive divided by negative, tan is going to be negative. So if I made 50 degrees off that, that's going to be 180 minus 50. That's going to be tan 130. But I know that's going to be negative. So to keep this positive and that positive, that needs to have an e in front, because that's going to give me negative. With the negative, make it positive. Similarly, I could also put another reference angle in here, which is 50 degrees here. So that would be like 360 minus 50. And that's going to be cos is positive, sine is negative, cos is positive, so tan will be negative. So that would be, again, I'd have to have negative tan, what did I say, 310. Or alternatively, I could even have it as also equal to negative tan minus 50 degrees. Because if you come negative 50 degrees when we start there, negative 50 degrees, I'm there, and that's equal to the positive tan 50. So you can actually have a heap of these. You can keep them going right around, right around, right around. And that's sort of what we're trying to do with reference angles. So where to from here? That. Where to from here, guys?